What I'm going to talk about, guys, in this unit is the exercise and physiology unit that we have in the muscular unit. As how a muscle is able to generate ATP. Remember, inside of a muscle, you got about 4 to 6 seconds of ATP, and then your body has to find another way to produce ATP, or the skeletal muscle will stop working, and these myosin heads will lock onto that act, and they'll no longer be able to get off. So you have to be able to have a way that your body's able, or your skeletal muscle is able to produce ATP in order for these skeletal muscles to work. So remember, the first thing you got to memorize is that you got about 4 to 6 seconds worth of stored ATP, and now we have to find another way for our body to be able to produce ATP inside that skeletal muscle for it to be able to function. This is an ATP molecule. Remember, when we're dealing with ATP, all you're doing is you're breaking down the bonds, and these bonds that you break down are going to be used to produce energy, and then this energy is going to be used to do something. In the case of skeletal muscle, this energy is going to be used to help these myosin heads get off the actin and be able to latch onto the next active site on the actin itself is what's going to be able to happen. When you break down ATP, it gets converted into ADP. So you can see here we go from ATP to ADP, and then energy is going to be released when we do this type of reaction. This energy is going to be used to derive some type of cellular process. Like I said, in the case of skeletal muscle, it's going to be able to use the energy to help these myosin heads lock off of the active site on the actin, and then be able to latch on the next one to get this muscle to move in that inward fashion to occur. Remember, in order for ADP to get turned back into ATP, we have to add energy to the system. So in order to go from here back into ATP, we have to add a phosphate in order to get it to go back to ATP. So that's all you're doing, is when you're regenerating ATP, you're taking ADP and you're adding a phosphate to it to regenerate ATP. So you have to put energy into the system in order to generate ATP, in order to get ADP to go back to ATP. So the first way that we're able to produce ATP is inside of a muscle. A muscle stores what we call, inside of it, we call it creatine, and we call this first process called direct phosphorylation. You may have heard of bodybuilders wanting to get creatine in their diet and things like that. Your muscle cells are one of the cells in your body that stores creatine, and basically what you're doing in direct phosphorylation, it's also called the phosphagen system, is after that initial stored ATP has been depleted, you're basically going to break off that phosphate off a creatine phosphate, give it to ADP, and then that's going to create ATP as a result. This will last about 15 seconds. The reason that power lifters and things like that like this creatine phosphate in their diet is because the activity that they do a lot of times with heavy lifting only lasts about 15 seconds when they're lifting these heavy weights. You're producing about 1 ATP per creatine phosphate molecule when you're taking a look at this particular process to produce ATP. This is what it looks like. You can see here. So creatine phosphate is donating its phosphate to ADP to create ATP, and in the process, then we're able to take this ATP, break down the bonds of it in order to power the skeletal muscle. A byproduct of creatine phosphate is going to be creatinine. Creatine is what we're going to produce as a result of this, and a lot of times you'll urinate some of this stuff out as well. But you can see this energy duration is going to last about 15 seconds. So after we go through this 15 seconds, now we have to find another way to produce ATP. And there's going to be 2 ways that we're going to be able to produce ATP in the muscle depending upon what's going on. The first way we can produce ATP is through aerobic respiration. And aerobic respiration, what you're doing is you're taking glucose, okay, and oxygen is present, and in the presence of this oxygen with the power of glucose, you're going to be able to take ADP, you're going to join it with P, with phosphate, you're going to produce a ton of ATP in this particular process itself. You're going to go through a series of processes in the mitochondria, and as long as oxygen is present, you're going to be able to produce a ton of ATP as a result of this. But the key to this situation is you have to have continuous oxygen being supplied into the muscle itself. So as long as you have a continuous oxygen supply and this skeletal muscle is able to get this oxygen supply, then you're going to be able to produce this this ATP for a long period of time. So you can see here, guys, you have glucose. Glucose is going to get broken down, and it's going to produce around 32 ATP per glucose that goes in, which is a lot of ATP. This ATP then is going to be used to, like I said, be able to power that muscle cell in order to get contraction to occur. A byproduct is going to be H2O and CO2. A lot of students ask, well, what if glucose isn't present? If glucose isn't present, your body's then going to break down fat inside of your body and use that fat to help drive the production of ATP by adding a phosphate to the ADP in order for ATP production to occur. If you're out of fats, then you're probably going to tap into your amino acids as the other metabolic pathway that you're going to go down. But this can last hours. But like I said, the key is you have to have oxygen present in that muscle. And there's going to be times, guys, when you're not going to have oxygen present in that muscle. And those particular times are like when you're really, really exerting yourself. Like if I'm sprinting as hard as I possibly can, not every single skeletal muscle inside my leg is going to be going through aerobic respiration. Some of them are going to have to find another way to produce ATP as a result because they're just overexerting themselves and they can't keep up. They can't grab enough oxygen in order to produce the ATP that they need to produce. So there's another way that we can produce ATP. It's called anaerobic glycolysis. It's also called anaerobic respiration. And basically, in anaerobic respiration, you're still taking the glucose, but the glucose is without oxygen. And as a result of that, you're going to produce 2 ATP. You don't produce as near as much energy as a result of this metabolic process. But as a result of this process, what you're going to be able to do is you're going to be able to produce this ATP a lot faster than the process of aerobic respiration. So it's not as efficient, but it's very fast when you take a look at it. A byproduct of this is lactic acid. So like I said, with aerobic respiration, it's going to produce CO2 and H2O as a byproduct. A byproduct of this is going to be lactic acid. Well, the thing you have to remember about lactic acid is lactic acid builds up in the muscle. If you get enough lactic acid building up inside the muscle becomes extremely acidic and it will stop working. The only way to get that muscle to work again is for that muscle to get replaced with oxygen inside of it for that lactic acid to go away. These are all reasons why you stretch and do those different types of things when you're done with an activity. You stretch prior to an activity that you're going to go into to deliver oxygen to that muscle so you can be ready to go into aerobic respiration. This is that process here. Like we said, ATP are going to be produced, net gain of 2, but you have this lactic acid that's produced as a result. This is just talking about muscle fatigue, and in order for muscle fatigue to be able to work properly, for a muscle to be able to work properly, it has to have oxygen inside the muscle in order for muscle fatigue to stop, because we have to replace that lactic acid with 1 oxygen. So in order for muscle fatigue to stop, you have to replace the actual lactic acid with oxygen coming into it, which is why, like during a sporting activity and things like that, you'll go through periods that you have to get rest, and when you rest, the oxygen is supplying back into that muscle to help relieve that lactic acid that's built up inside of it, and then you get going again. You can go back at full speed for a given period of time. 2 types of muscle contractions that we have. We have an isotonic contraction, and an isotonic contraction, the myofilaments are able to slide across one another, so you have complete contraction. These myofilaments are able to slide completely across one another. That's an isotonic contraction. Isometric contraction, you have tension that builds up in the muscle because these myofilaments can't do a complete slide across one another. So like an example of that would be like pushing against the wall. I can't move that wall. So what you have is these myofilaments, basically a lot of tension builds up in that muscle, and you don't have a complete contraction. With an isotonic contraction, you have full range of motion, you have that full contraction that can occur. Talk about muscle tone. People go to the gym and they want to get toned and stuff like that. All muscle tone is that muscle fibers are going to contract even when you're sitting there and you're really doing nothing. Even when you're in a relaxed state, you still have continuous firing into the actual skeletal muscle to keep them active, to keep them firing, to keep them going. In case you get into some type of crisis, they're ready to go. So they're constantly ready. Exercise, 2 types of exercise. You have aerobic exercise. And aerobic exercise, what you're going to do is you're going to increase the endurance of the muscle. So a muscle can become a lot more resistant to fatigue. It's going to make your metabolism a lot more efficient. It's going to improve your digestion, your coordination, those different types of things. It's going to make your muscles stronger as well, make them more flexible as well. But that's your aerobic exercise. This is like when you're running long distances, things like that. Is going to work on your aerobic with the exercise. The other thing that you have is you have isometric exercise. Isometric exercise is going to work on the muscle size and strength, is what it's going to do. as a result. So muscle size and strength, this is going to be like your lifting exercise, lifting weights, doing those different types of things. Are your two different types of exercise you can do is aerobic and then your isometric training. These are examples of the two types of exercise that you have depicted here. Here's your aerobic, and then here's your isometric training that's going on. So you can see, guys, in this lecture itself, you can see that basically you have three ways in which a muscle is able to produce ATP. One is the phosphagen system, or the direct phosphorylation. Then you have aerobic and you have anaerobic. Remember, all that you're doing, guys, is you're using the ATP. You're breaking the bonds of this ATP, and they're using the energy from breaking these bonds in order to get a muscle to be able to contract, is what you're going to be able to do. Aerobic can last forever as long as oxygen is being supplied to the muscle itself. Anaerobic is going to last a given period of time until you have increased buildup of this lactic acid inside the muscle, and then the phosphagen system lasts about 15 seconds.